remember that yesterday we talked about imaginary and complex numbers and how they fit into this system and how to use them. So today, your examples that you're going to write down are just going to be the basic uses of them. So it's lots of little ideas. And then you guys can start homework number 10. So in the first problem up here, which some of us did in class, when we look at the square root of negative 24, we said to think of it as the square root of negative 1 times the square root of 24. The square root of negative 1 part is where we are now seeing this new idea of the imaginary number I, so we could actually use the negative radical. And then the 24 part is going to break down like it normally would. So 4 is a perfect square. There are no perfect squares in 6. So this would be 2 rad 6. And how you would probably see this written is 2I rad 6. So that's just simplifying radicals that have negatives in them. The next idea we want to see is how we would solve equations like this. So in part A here, first thing I would do is subtract 12 from both sides and then divide by 3 and square root both sides. So normally we'd stop here and say no real solution, but this just says solve and doesn't really say if they only want us to solve on the real number set or not. So I definitely would continue. So you would get two complex solutions here, positive 2I and negative 2I. The 2 because 2 is the square root of 4, and the I because I represents the negative in the radical. For the next problem here, maybe the first thing we would attempt to do is we would attempt to factor. Oops, this should be a minus. So I took out the negative, and then my goal would be to look here and see if I could factor this. Now, there aren't any two numbers that multiply to make 5 and add up to make negative 4, so it's not factorable. So I'm going to scratch this. I'm going to go back to the beginning, and I'm going to try to use the quadratic formula. So negative b plus or minus square root b squared minus 4 times a times c all over 2a. So this gives me negative 4 plus or minus the square root of, and underneath this radical, we have 16 minus 20, so it would be negative 4 over negative 2. So normally we would stop here and say no real solutions, but if they haven't directed us to only use real numbers, we're going to continue using complex numbers. So the square root of negative 4 is going to be 2I. And then because these can all be divisible by 2, we can simplify this. So negative 4 divided by negative 2 is positive 2. 2I divided by 2 is 1I. And as far as the signs there, there's both a positive and a negative. So yes, I understand that when you divide a positive by a negative, it becomes negative. But a negative divided by a positive, a negative becomes positive. So basically, you're going to still have a plus and a minus there. So we would write our two complex solutions this way. Remember to pause the video whenever you guys need to copy down the notes. All right. So now we're going to talk about graphing complex numbers. This is a really kind of distinct section. It's not like we use this all the time on any graphs. We only use this specifically when they say to graph a number. And when they do that, instead of calling this the x and the y-axis, we're thinking about it as the real axis and the imaginary axis. So remember that yesterday when we talked about imaginary number versus complex number, imaginary number just had the I part, but both of these numbers here are complex numbers because they have a real part and an imaginary part. So in this case, 1 is the real part, negative 3i is the imaginary part. So basically, you're going to plot the point 1 on the real axis, negative 3 on the imaginary axis. That's going to be your point. So it's very similar to plotting the point 1, negative 3, because it's 1 for real, negative 3 in the imaginary direction. And then in the second example, it's negative 4 for the real. So we're going to go negative 4 on the real axis. And then I is like plus 1i. So we're going to go up 1 on the imaginary axis. So that would be our point, -4 plus I. Okay, so just like graphing an ordered pair, if you've renamed the axes, again, we won't use this like on graphing a parabola. We're not going to also graph imaginary things. That's all real numbers. You would be doing this separate from those. So it would only be specifically if you were asked to do it. All right, so operations with these things. How do we add, subtract, and multiply them? So you add, subtract, and multiply these problems the same as you would do if I was a variable. So like in the first problem, part A here, 2 plus I plus -3 plus 3I. We're going to add together the real parts as like terms. So 2 plus -3 is -1. And we're going to add together the imaginary parts. So I plus 3I is 4I. So our solution here, when these are added together, we get -1 plus 4I. Subtraction is going to be the same idea, except for just like we would with different quantities that had variables in them, we would distribute the negative to see the true signs of these values after the minus sign. So we distribute the negative to the 4 and the 2i. So we'd have -4 and -2i. And then we would combine the real parts. So here we'd get -10. And the imaginary parts, so we would get -4i. All right, and when multiplying, which some of the classes saw yesterday, we're going to do the same process we did before, whether you think of it as FOIL or the distributive property. We are going to distribute each term from one binomial into the other. So 5 times -4, -20. 5 times -3i is -15i. -7 times -4 is 28i. And -7 times -3i is positive 21i squared. Okay? So we have like terms here, and then we have some imaginary parts that can be changed into real numbers. Because remember, we do not keep different powers of I. It's either I, and if it's a power of I, it simplifies to be something to do with 1 or with I. So we have -20. These two terms combined together, so -15i plus 28i would be positive 13i. We have plus 21, and that 21 is being multiplied by I squared. I squared is the same thing as -1. Don't forget that the 21 is multiplying the I squared. Just like if I was an x and you were plugging in a value for x, that's multiplication there without a symbol between them. So this is -20 plus 13i minus 21. So this is -41 plus 13i. And so there's our complex number with its real and imaginary part. In part D, the problem is special, just like our factoring pattern is special. So if you guys remember when we factored things like x squared minus 4 when they were missing a middle term, we factored as x minus 2 and x plus 2. And that's because when you multiply these out, you get the squared term. You do still get middle terms, but because the factors were exactly the same with different signs between them, these two middle terms cancel each other out. So the same idea happens here with a problem like part D, when you have these two factors that look so similar with just a different sign between the imaginary part. And you might want to make a little note. These are called conjugates. And so what I mean, how you would use that word is like 4 plus 3i is the conjugate of 4 minus 3i. Or 4 minus 3i is the conjugate of 4 plus 3i. So again, this has the special property that as we multiply these together, we can follow the same multiplication procedure. And we're going to see that it has this special property because it uses the same numbers again and again, that we get these portions that cancel out. So 12i and minus 12i will add up to 0. So we have 16 minus 9 times I squared. And remember that I squared is valued at -1. So this is really like having 16 plus 9, which is 25. So again, this is the important part about the real or the imaginary numbers or complex number system, is that they have this distinct connection back to the real numbers. Okay? All right, the last thing we're going to look at is what to do if these are being divided. And this is going to be really similar to radicals or things you might have used before. So basically, when we have something like 8 plus I over 7I, this is fine. There's nothing we can really do to simplify it, except for it's not written correctly because the denominator is not a rational number. Right now, it's not even a real number. And remember, we cannot have things that are not rational in the denominator of our fraction, like our English grammar rules, but for math. So basically here, I want to make I squared because I know that I squared will become negative 1. So all I have to do in this case, since the number in the denominator just has an imaginary part, is I just need to put in another factor of I in that imaginary part, because what that will do is that will create a denominator of 7I squared. Okay, and the I squared will turn to minus 1, and that will allow me to simplify. The thing is, I cannot just change a problem by putting what I want into the denominator. So mathematically, how we don't break any laws but are still able to do this is since we multiplied a factor of I into the denominator, with the way that fractions work, we'll also multiply a factor of I in the numerator. So we will have 8I plus I squared. Now I can see with the 8I that I'm still going to have an imaginary part to my numerator, but that's completely okay. I was just concerned with rationalizing my denominator. I want my denominator to be a real and a rational number. So then I'm going to rewrite everything that is I squared as negative 1. And I'm going to simplify. So in my numerator, I'm going to go ahead and write the real part first just because that's how you guys would see it most of the time. I have negative 1 plus 8I. And in the denominator, I have negative 7. And this doesn't really simplify, so it's okay to leave it like this. You might see them simplify the negative out of the denominator. So if you distributed this negative to each parts of the numerator, you may see the solution written like this. Okay. Now, in part B, it's a little bit more complicated because the denominator has two pieces. So don't write this down. But if I take 3 minus 2I, which is in the denominator, and I just multiply it by I, look what's going to happen. Yeah, I'll get negative 2I squared, and that's helpful because it will turn to minus 1. But I'm also going to have 3I, and I'm still going to have the imaginary part that I don't want. So the solution here is not as simple. Okay? We can't just multiply by I in the denominator. So we want to go back to the idea that we saw before. How do we take a more complex number that has both a real and an imaginary part and get it so that it just turns into a real number? And we saw back here in part D that happened when we multiplied together conjugates. Same real and imaginary part, but with a different sign in front of the imaginary part. So here, when the denominator is 3 minus 2I, I want to take that and multiply it by 3 plus 2I, its conjugate. If I choose to do that in the denominator, I have to do the same thing in the numerator, so I will. And now I have a lot of multiplication to do, okay? So in the numerator, I'm going to get 15, so I'm just distributing or FOIL, okay, plus 10I plus 6I plus 4I squared. And in the denominator, I'm going to get 9 plus 6I minus 6I minus 4I squared. So in the denominator, notice that the imaginary parts canceled, which is exactly what I wanted. Okay. And then in the numerator, that doesn't happen, and I'm going to make sure all of my I squareds get replaced with negative 1. So this is 15 plus 16I when I combine these two like terms, plus 4I squared. But I squared means that 4 is getting multiplied by negative 1. Then in the denominator, I have 9 minus 4 times I squared, but again, that's a negative 1. So right here, negative 1 times 4 is really just like I have a term of negative 4 here, and negative 4 times negative 1 is like I have plus 4. So I'm going to combine the real number parts in both the numerator and the denominator to get my final answer. So 15 minus 4 is 11. I have a plus 16I. And in the denominator, I have 9 plus 4, which is 13. There's no number that divides 11 and 16 and 13, so this fraction cannot be simplified further, and I would leave it in this form. Okay? So that's how we would simplify fractions that have imaginary numbers or complex numbers in the denominator. So your homework tonight is homework 10. You can get started in class. There's not enough books for everybody, so share where there are books, turn your desks if necessary, or use your devices to take a picture of the page and take that back to your desk with you. All right? Good luck, you guys, and I will see you on Monday.